Good afternoon, sir. My name is Sonal Maheshwari and my title of presentation is Valorization of Petroleum Residue to Graphene.
Your name, Sonal?
Sonal Maheshwari.
From which organization?
Bharat Petroleum Corporation Limited.
BHCL.
BPCL, sir.
BPCL.
BPCL. So here as the product says, like it is a valorization of petroleum residue. Valorization of petroleum residue, which is the residue is called vacuum residue or pet coke, which is the last material. And cost of this material is not more than 7 rupees or 8 rupees per kg. And here the objective of this product development is to valorize this product to a product which is costing you almost 15,000 to 25,000 rupees per kg. And since this material is a unique material which has got Nobel Prize in 2010 in physics, but still this material could not see the light of the market till now in the commercial scale. So now BPCL has put in its effort from petroleum coke to convert into graphene, and we have got success till quite a good stage. And application of this product is in supercapacitor, batteries, solar cells or paints. So it has got wide application, and since this material is having very high electrical conductivity and mechanical strength, it can be utilized in supercapacitor very easily. So for understanding of everyone, I'll just compare the graphene and carbon steel properties. So you can see the electrical mobility of this material is 2000 centimeter, 20,000, not 20,000, even 2 lakh centimeter square, and electrical conductivity is quite good compared to carbon steel, and thermal conductivity is very, very high. So this material has got a strength. So when you are using it in supercapacitor or batteries, this material is going to give you miracles. So here are some studies which we did, characterization of this product. This is Raman spectroscopy of the raw material and the product. Here what we have tried is like, it is very simple step from coke to graphene is like you have to prepare graphite. But as you might be aware that graphite manufacturing is a high temperature process. So here the innovative part which we have done is we are trying to bring down the graphitization temperature by using catalyst to 900 degrees centigrade, which is huge energy saving. So from these graphs and these studies, we can see that it has got a very good potential of making graphene. And these are electrochemical studies, and which these electrochemical studies also says that graphene oxide prepared from coke is having electrical conductivity and energy density, which is quite good in comparison to the raw coke product. And we have to improve upon these recipes. Of course, at lab scale we have developed this. Second stage is graphite to graphene. So when we have prepared graphite to graphene by mechanical exfoliation, we could see that we are meeting the product qualities with the commercial product quality. And from the first column of the slide itself, you can see graphene which we prepared is having surface area of 507 meters square per gram and 690 meters square per gram. So which means 1 gram of material can spread into area of 690 meters square, which is actually a very high quality material, and it is having 2 to 3 layers of single carbon. So coming to the conclusion of this, like coke presence in the catalyst has giving good potential of graphene production, which can be used for making supercapacitor, lithium ion battery, polymer and paint industry. Graphene is foreseen as a breakthrough material of 21st century. However, commercial production is still a challenge. But seeing this route, we could see that the current option which we have opted may help us in a feasible solution for making it a commercial product. Thank you very much.
Thank you. Next, please. Name and title?
Yeah. Good evening, sir. My name is Arun Rajagopal.
Arun
Rajagopal.
Arun Rajagopal.
Yeah. The title of my presentation is Production of 100 and Group 3 Base Oil.
Company?
Company is Mumbai Refinery, Bharat Petroleum Corporation Limited.
BPCL?
Yeah, BPCL, yeah.
Mumbai Refinery?
Yeah.
Title of your presentation poster?
Poster is production of 100 and group 3 base oil.
Production
Of
Group 3.
100 and group 3 base oil.
I think your title, spread it full page.
इसमें zoom करो, इसमें zoom करो.
Okay.
Yeah. So basically the unit from which this innovation, what we have done is from hydrocracker, integrated hydrocracker LOPS unit, which we have in Mumbai refinery. It has basically 3 blocks. One is the hydrocracker block, wherein it is a 2-stage hydrocracker unit, wherein it achieves 84% conversion of 84% conversion of vacuum gas oil, and unconverted oil is going for production of lube oil base stock. So for making lube oil base stock, there is a feed preparation unit wherein we cut the unconverted oil into various cuts, that is 65 N cut, 150 N cut and 500 N cut, based on the viscosities and the size of the molecules. We cut it into various fractions, which we send to LOPS DW unit, wherein we pass it through 2 reactors. One is dewaxing catalyst, wherein isomerizing of and normal paraffins is happening, and hydrofinishing is also happening. So there was a requirement of the product called 100 and group 3 base oil, which has been historically imported. Around 15 TMT of consumption is there in India, out of which all 15 TMT have been imported, and BPCL requirement is around 4 TMT per annum. So it is to come from Korea and basically Middle East. Yeah. So the speciality of that particular product is it has got limited manufacturers. It's a premium quality base oil. It has got better profitability. It has on RTP base around 40,000 rupees. The price is higher per ton, and it has got a growing market potential, considering that the automobile segment is moving towards lighter engine oils. So the salient features of the product are one is the high viscosity index, lower evaporation losses, premium cold properties, and better engine efficiency. So this particular product was produced for first time in Indian refineries by BPCL. The main innovation involved are the following. The main challenge was identifying the right feedstock. So this particular product, it has not been produced in India. One of the primary reasons is you always don't have the pure, high VI crudes feeding into our refineries all the time. So the selection of the right crude mix was one challenge, which we achieved through our in-house database. Then the conditions in the hydrocracker unit, it's a 2-stage process. So the per pass conversion was shifted from the 2nd stage to the 1st stage, so that one particular set of molecules are produced more, and the 100 and group 3 base oil raw material is yielded more. So that kind of severity adjustment was there, was done, and using an iterative process, the right kind of severity in the LOPS unit was found out, wherein the NOVAC, that is the volatility properties, are not breaching, while we also preserve the viscosity index of the product. So the conditions we achieved using multiple trials. So as per the acceptability of the product has been approved by Kia Motors and Honda Motors. The product was sent all the way up to Japan, and they had given the approval. Only then they were using, and it is under approval and validation by TVS and Hero Motors. So major product specifications are like kinematic viscosity. It's a very narrow range of 4.1 to 4.5 CST. Viscosity index is 125 minimum. So group 3's category is 120 plus, and whatever we are producing, it is around 125 in and around. Pour point is around minus 18 degrees. Otherwise, normal lube oil base stock is minus 12. So it has got premium cold properties also. Then apparent viscosity is at minus 25 degrees is 1500, and evaporation losses is less than 14.5%. So the resources used, it's all in-house generated idea, internally implemented, and the data analysis was all done in-house, and we used our CRDC tool called BPMA to select the right kind of crude for this particular thing. The other impact areas are, one is the replicability. If we have the right kind of crude and similar configuration, this can be replicated in elsewhere also. And other impact area is the net zero and net zero. Though there is no direct impact on energy intensity index, since we are backing out some diesel and putting lube oil, increasing the stock of lube oil, so some scope 3 emissions are reduced, and to the equivalent of around 12.7 metric ton per CO2 equivalent per annum. That's
okay.
also. Thank you.
Thank you. Next, please. Your name?
Same, Anirudh Kulkarni.
Yeah, Anil Kulkarni from BPCL.
Yeah, BPCL.
Title of
K model.
K
Model, yeah, K model.
K stands for?
K stands for a lot of people who's working on the project. Their name starts with K, that's why.
Okay.
The main inventor is Dr. Rajiv Kumar. So yeah.
Okay.
So basically, it is a web-based software for prediction of crude compatibility.
You want to say K stands for Kulkarni?
Yeah, you can say, because I'm the part of the yeah.
Okay, carry on.
Sure. So basically, K model is a web-based software for prediction of crude oil compatibility. As we all know that in refinery, we are processing crude in like blending of the crudes. We never perform like process crude in the single crude. So sometimes it happens that we are processing the crude with the 4 blends, like 4 crude blends or 5 crude blends. And if just a minute, slide is not moving. Excuse me. No. स्लाइड मूव नहीं हो रही है, वही तो बंद हो गया। वो तो मैं आपका ये वाला नहीं, उसमें प्रॉब्लम नहीं है, आप उसको ऑन कीजिए, ऐसे मिलता है उसको बिना स्लाइड मोड। So basically, what happens in refinery, we mix crude, heavy crudes, and like soft crudes, and to have the better cost reduction and everything. So when we have to check the crude compatibility also. If they are not compatible, then what will happen? There will be asphalt precipitation, and then it will fouling of the happens with the crude preheat train. And again, there will be less heat transfer loss, and again we'll put more energy in the furnace before processing the crude. So at present, if I talk about the present conventional methods, there are total 9 tests which we need to perform for the crude compatibility. If you have 2 crudes, it will take around like 1 to 2 weeks to find out the compatibility. And if you have 3-4 crudes, then you have to fix first 2 crudes, then again you add 3rd crude. So normally if you are blending 4 crudes at a time, then it requires almost a month of time to find the crude compatibility. So what we have done at our R&D center, based on our past experience and various laboratory methods and our mathematical model we have developed, and this is the first time in the world we have developed this K model, which runs the lot of simulation models in the background, and will predict the crude compatibility up to the train crudes within just a minute of time. So it is a basically web-based tool. We call it from the conventional method of a laboratory experiment. We have prepared this digital tool, and this is designed by our own corporate R&D center team, and it is available on the BESS. So, and we are using it in our refinery from last 3 years. Every year we are almost saving for each refinery 200 crores revenue. This crude is also helping us. How it works. Basically, you have to input only just 4 parameters. You can input around like 10 crudes at a time, and it will give the results in the percentage also. Like if suppose we are performing the conventional test, we may blend 1080, 1090, 2080, but our tool can predict the 55.5 also, like in the 2 decimal also it predicts. So the K model is having these 5 different modules at present. The first one is a crude blend compatibility, one is without optimization, one with optimization. So in the first case, which is the base solution, it will give it to us. In the second case, with optimization, where you can put the constraint of the cost also. At this cost, you have to blend the reverse thing. So if you put the cost constraint or the yield constraint in the second 1B module, it will perform the reverse calculation and it will give the which is the base blend. If you want to process crudes with the bitumen potential, then also you can use the same thing. And the last one is the fuel oil blending. So apart from this, if you use this crude K model tool, it is helping us on HSC benefit also, because ultimately the compatibility is getting better. You are going to putting less energy in the consumption, or it will reduce the CO2 emissions also. So till now we have got around like 9 patents has filed on this invention, and from last 3 years we are using in all the refineries of the BPCL. Even our SEO team, which is crude procurement team, they are also using this software tool. And now we are going to launch this product outside BPCL. We are going to launch in the January itself. We have got the inquiries from the US and other companies also for getting this tool. So this tool is like, normally what happens if you want to ship, like we call digital transformation. What we do, we go outside the market, which is the base tool available, we buy it and we install it. But no, BPCL is taking the other way. We thought we will be self-reliant towards our thing. So we are developing our own tools, which are cost-effective also, which is saving money also, and we have the control over it also because we have developed these tools. So we call it self-reliance towards the digital transformation. So we have launched this tool.
Thank you.
Yeah, thank you.
Next, please. Name, please.
Good afternoon, sir. I am Antara Das. I am from Engineers India Limited.
EIL.
EIL, yes, sir. And
No, just name again.
Antara Das.
Anchira.
Antara, sir.
Antara.
Yes, yes.
Antara Das.
Yes.
Antara Das. Title of your poster?
Yes, sir. The title of my poster is Assessment and Reduction in the Water Footprint in Indian Refineries.
Okay, please carry on.
Thank you so much, sir. Thank you. So it's moving now. So we have heard about oils in this presentation. So I'm going to talk about a different topic, that is water, which is used in a quite large quantity in all these oil refineries actually. So we have done a study for water footprint reduction in the Indian refineries. So what is water footprint? Water footprint is the water required to process 1 MMTPA of crude oil. So we represent it in a term of meter cube of water used to process per MMTPA of crude. So for reduction of water, and why we require to reduce this water, because when we done the study, we have seen that a large quantity of water, which is fresh water, is used as a processing part for the refineries, and for the sustainable operation for any refinery, we need to have reduction of this fresh water portion of my total water uses of a refinery. So for this, the methodology that we followed, we have visited 13 Indian refineries for various clients of us. We have gone for interaction for each unit level. Like for CDU, we have interacted with the operators, with the engineers, for everything.
Move the papers.
Yes, of course. And from that data, we have done water balances across the refinery to identify the avenues. I'm sorry, the slides are actually not moving. Okay, sir, I'm so sorry. Actually, the slides are not moving. It was moving here.
Presentation more.
Okay.
This presentation.
Basically, you have to present the poster and then speak.
Yes, sir. It's not moving there actually. What? Yeah. Is there? It's not coming, no?
No,
Yes, present.
Excuse me.
So it was green at least.
डबल खोल गई है फिर दोबारा हाँ डबल खोल रखी है स्लाइड वाटर ये वाला वाटर कौन सी वाटर स्लाइड शो है ना
So the presentation
ये है
is
ना,
not
ये है ना?
representing. Can I just
ये है ना?
represent my poster and talk?
एक घंटे तक देखो ना ये है ना ये है
हाँ यही है.
कोई नहीं रुक जाओ क्या प्रॉब्लम तो आती थोड़ा ये क्यों आ रहा क्यों है
People poster.
How many
भी
sheets you have?
प्रॉब्लम है इसमें कुछ
Sir, 6-7 only. 6-7 PPTs.
Okay, if you have problem, we may go for next only, because basically it is a poster presentation.
Yes, yes. सर मेरा पोस्टर ही खोल दीजिए, प्रेजेंटेशन हटा दीजिए, पोस्टर खोल दीजिए, मैं पोस्टर से बताऊँगा. ये पोस्टर क्या है? Sir,
Okay, who is next available?
myself
You can try meanwhile. We'll call you again.
yeah, sure, sir. Thank you.
Who is next, please, after this?
yeah
This. Okay,
yeah,
come.
yeah. We'll also try ये भी नहीं आ रहा
What's your name?
So I'm Anindo Rai from Engineers India Limited, EIL. Anindo Rai.
EIL.
Yeah.
What's your name?
Anindo.
Anil Dhar.
Anindo. ANINDYO. Anindo.
Anil
Rai.
Do.
Anindo Ray. RAY.
Anil Do Ray. Oh,
Yeah.
okay, okay.
Yeah, yeah.
What is the title?
So title is Earthquake Early Detection.
Okay.
Earthquake Early Warning System.
Early
Warning System.
warning system. Please carry on.
Yeah. So good afternoon, everybody. Good afternoon, respected chair. I'm representing Engineers India Limited, and here we are going to give a small talk on the earthquake early warning system. Our technology partner in this is CSIO, Central Scientific Instrument Organization. So,
I'm sorry to interrupt. I'd request all the students to please not chat amongst yourselves. Girls, please. There's a lot of disturbance. Thank you.
Yeah, please carry on.
yeah, sir, ये थोड़ा देखिए तो it's not moving. कंटिन्यू करें? ये
तो कुछ स्लाइड पता नहीं क्यों ऐसी बनी हुई है।
तो
कौन सा वाला?
अर्थक्वेक।
इसी भी चलाना, ऐसे रखना, ऐसे भी चलना आगे बस।
ऐसे?
हाँ, बस ऐसे भी।
Yeah, okay.
Yeah, please carry on.
So I'll just carry on. It's an earthquake warning system. It's a technological intervention to avert loss of human life and infrastructure. It is not an earthquake prediction. Earthquake forecasting is not yet possible. But what we are trying to do is it's an early warning system before the actual ground shaking starts. So before the actual disaster happens, a few seconds before that, we are trying to give a warning so that some basic precautions, basic preventions can be taken. The solution provided is to activate the appropriate actions for safety during impending earthquake and devised for regional notification of a substantial earthquake while it is in progress. This is a brief picture of the movement of the Indian tectonic plates, and this is the fault lines that are shown. These are the seismic zones which are currently mapped in India. So we have some of the locations like Uttarkashi to Latu to Chamoli to recently in Bihar and Nepal. All these earthquake and their magnitudes have been mapped here. These are the seismic zones which have been taken from the Disaster Management Authority. Now the principle of operation. The principle of operation, why we said this is an earthquake early detection system. The principle of operation is that there is a time delay between the arrival of the primary wave, which is a straight line as you can see, which is non-destructive, and the secondary wave of an earthquake at a location to generate warning on detection of the P wave. Further the epicenter from the location, more time is available. Now the primary wave travels approximately at a speed of 8 km per second, and the secondary wave is much slower but is more harmful, and that travels at a rate of around 3 km per second. So approximately as a rule of thumb, for every 100 km from the epicenter, we have a time difference of approximately 10 seconds between the arrival of the P wave and the arrival of the S wave. This time difference is the time during which we can detect and take some critical actions to avoid the big disasters from happening. The earthquake warning system consists of a network of seismic sensing nodes, each consisting of a seismic sensor, GPS antenna, communication module and power supply module, and it is connected, all the seismic sensor nodes, that is SSNs, are connected to a central control unit, which is a server for generating the alert signals. The functioning of the earthquake warning system is that if a node detects an event, it sends the signal to the central control unit, and if more than R nodes, which we can define the signal, it generates an alarm, and based on the simultaneous activation of certain number of sensors which we can pre-program, we can generate the emergency alert delivery system, which gives the SMS and notifications to all the concerned authorities in the immediate vicinity. And after generating an earthquake alarm, this keeps on monitoring the seismic signals and update intensity level if signal value increases. The location of the seismic sensing nodes are also mapped here. These are strategically located to gather information about seismic activity and communicate to the central control unit. And these are all networked. The main features is the seismic sensing node is basically an accelerometer sensor, processor and IoT communication, and it gives the sensing signal as well as its diagnostic health to the central control unit, where we have a graphical user interface. This displays the latest true seismic event, which is sensed by more SSNs along with the peak ground acceleration. The peak ground acceleration is basically, if it is less than 0.039, that means it is normal. If the peak ground acceleration, that is the PGA, PGA is what the accelerometer sensor is measuring and transmitting. If it is around 0.18, it is moderate intensity seismic activity. Greater than 0.18 is strong. So if the two or more sensors in the close vicinity are sensing a seismic activity with PG of greater than 0.18, that gives an alert to the earthquake early detection system that the P wave has arrived and before the secondary wave is about to come. So within this arrival of the P and S waves, we can take some initial primary isolation and emergency evacuation activities. The SSNs are installed at number of identified field stations depending upon geographical coverage at vital installation. Basically, these are mounted on pillars, and this is the software, the GUI that we are talking about, the graphical user interface. That is, this comes to the central control unit like this, where it is being monitored. The different SSNs which are covering a particular area are all graphed here, and the SSN which has sensed the seismic activity goes into red mode or amber mode depending on the sensitivity or the seismic activity. These are all the earthquake events that are detected. The earthquake warning alarms have a standard operating procedure with do's and don'ts and the recommended precautions. The preemptive actions once the P wave is detected and once earthquake warning alarm triggers is: do not initiate any start sequence operation, not to start any loading or unloading operations, stop conveyor carrying functions, stop lifting cranes, stop welding activities, do not start any fire, move away from dangerous machines, evacuation from areas at risk of being significantly contaminated by hazardous substances, automatically shut down and isolate industrial system based on ground acceleration data, halt assembly lines at factories, and remotely close protective gates and the sides of seawater making channels. Vehicles also can slow down. If the earlier one is regarding some refinery or other installations, and here on the highways also you can make the vehicles to slow down and refrain from entering bridges and tunnels, slow down high speed trains, stops to or slow speed trains, do not start standing trains and planes, delay landing of aircrafts and brace position in standing aeroplane during emergency. All these things will can happen in a 1 minute time interval between the P and the S wave, and therefore we are calling this as an early detection. Preemptive actions are: persons who are indoors can take cover, persons who are outside can move towards open space, persons to avoid entering lifts, stop lifts, persons to stay away from glass doors, persons near coast should not go towards sea, and make operations and emergency departments ready and open fire station doors. Current installation is done at Delhi Metro. It is running and operational since 2016, and this has been found effective when we recently had the earthquake on November in the midnight. So this early earthquake sensor detection was able to accurately detect and give the early warning system. So thank you.
Thank you.
Thanks.
Next, please.
क्या होता है एक स्लाइड कर देगा ना तो ये तो उसमें है ऐसे कोई स्लाइड्स होते जाओगे ना तो वो एक आएगी पूरी नेक्स्ट स्लाइड बढ़ती नहीं क्वेश्चन ये
जाएगा
ये ना हाँ इस मोड में नहीं देना इस मोड में चल नहीं रहा ना आगे तो चलेगा तो चलेगा तो लोग
Tell me your name, please.
Good afternoon, sir. My name is Srinivas Prasad.
A bit loud.
Srinivas Prasad.
Srinivas.
Prasad.
Srinivas Prasad.
And my colleague Amit. We are from BPCL.
You are from BPCL.
BPCL.
What is the title of your poster?
Integrated Refinery and Petchem.
Integrated
Refinery and Petchem.
Refinery
and Petchem. Petrochemical.
Come on.
This is our poster, sir.
Integrated Refinery and Petrochemical Project.
Yes. Okay.
Carry on.
Yeah. Sir, we were asked, good afternoon to all. We were asked to evaluate a project which is $5 billion project, which is planned to set up in Bina Refinery of BPCL Group Refinery. So what we were asked is, do feedstock evaluation of what would be the probable feed for this petrochemical refinery. So what we did here is...
But is there a petrochemical already existing?
No, sir.
So it is a new one?
It is a new one.
Whereas a refinery is an old one?
Refinery is already there.
Carry on.
Yeah. So we were asked to do this thing, but the problem here is the future is very volatile, uncertain, complex, yet ambitious. So we do not know if the transportation fuels demand would decline, be steady, or go up. So what we did is, typically all the petrochemical plants for this ethylene cracker, they have 90% naphtha as the feed. Naphtha is the feed for all the ethylene crackers. What we thought here is, instead of naphtha, what we can do is, we can keep an option wherein the crude unit ranges, which goes from kerosene to gas oil, which is used for diesel, that can also become a feedstock for this ethylene cracker. So that in future, if the transportation fuel demand comes down drastically, this can become a feed to my petrochemical unit. And refinery and petchem can become a collaborative one. Instead of reducing the refining and ramping up the petrochemical, now both of them can run in tandem. Now just imagine if the transportation fuel demand itself does not come down. Still the option you will have is, we have two more refineries, Mumbai and Kochi. That naphtha which is being exported, that can be used as the feed to this ethylene cracker. To sum it up, this is what we have done, and also we have evaluated this in linear programming model, which is a mathematical model. And what we have done here is, I mean, any licensor, if they would have done this study, they would have charged 1 crore rupees. This we have done it in-house through our people in 1 month of time. So this
is it over? You got any other slide?
No sir, this is our poster. Single poster.
Okay. Thank you.
Thank you sir.
Next please.
मैं अभी आगे वो IT वाला आगे दिखा रहा कौन सा वाटर वाला ये ना थर्ड ये वाला नीचे से थर्ड ये ना ठीक है अब देखना है एक मिनट उसको पहले एक्सटेंड नहीं ना उस टाइम नहीं चल रहा है ठीक है
Good afternoon, Chair Sir, and thank you so much for giving me a second chance.
Please start.
Yes, my name is Antara Das.
Antara Das.
EIL, and my topic is assessment.
You are talking of assessment and reduction
of water footprint in Indian refineries.
Yeah. Water footprint.
Yes.
Please carry on.
With the aim of reduction of water footprint for a sustainable operation of refineries, a study of 13 refineries among India for our various clients were done. The aim of the study was to optimize the freshwater consumption of the refinery and recycle of the treated effluent by putting up recycle plants and by mitigation of the already available recycle plants, so that recycled water portion is more in the refinery and fresh water consumption is less. We have also aimed for the reduction of freshwater consumption by putting up alternative sources of freshwater generation. So there is a representation of all the 13 refineries whose capacity is ranging from 0.65 MMTPA to 9.75 MMTPA. For assessment of this water consumption, first we need to know what is the factors on which the water consumptions for a refinery is dependent and which are the major components for this water consumption. If we see the pie chart, the major consumer of the water in a refinery is basically the cooling water circuits for the cooling water makeup. And the next component is the DM water, that is the fresh water required or the recycled water required for production of DM in a refinery. And the other components mainly constituted of service water, drinking water, horticulture, fire water, and in some older refinery we have identified some unaccounted losses through the underground networks. So the water demand which a refinery actually requires, it depends on various factors. I will go to the graphs also to show you the pattern of the water requirements. But the pattern more or less is like with capacity increase, of course the water requirement is increasing, but there is some dip in some of the portions, and the various factors are, one is complexity of the refinery. Suppose a lower capacity refinery, if it is having more complexities like more secondary units, then the water consumption pattern is more with respect to a higher capacity refineries. Another major factor is the feed water quality. It majorly depends on the same, since the major consumer is cooling water, and the feed water TDS is a dependency of how much COC a cooling water can run. So this is a major factor, like the coastal or near to coastal refineries where the freshwater TDS level is high, their makeup quantity is also high because the COC would be lesser for the cooling water circuit. Availability of recycle plant, that is a very important factor, because if we can recycle our own effluent that is generated, then of course the freshwater consumption figure would be much lesser, and this would be a very good example of a sustainable operation of a refinery. If we go for a figure which is produced by the World Bank, the effluent generation is almost from 1 to 1.5 meter cube per ton of crude processed. So this high quantity of effluents, if we can recycle, that would be a very good impact on the total freshwater consumption. Other points are condensate and blowdown recovery, the unaccounted losses if we could tap on them, and the steam like from condensate from the steam traps, if we can trap them, then that will reduce also the water consumption. This is a typical representation for all the 13 refineries, the major components of the water that is required for them, and the pie charts and this graph represents the same, that is the major consumer is mainly the cooling water makeups, then the DM feed, and then the other uses as I have already discussed. And in our 13 refineries, there were 2 coastal refineries also, so we have represented that in a separate form, because for the coastal refinery the difference is the cooling water networks are mainly based on the sea water. So the freshwater consumption figure would be lesser for the coastal refineries. Now this is a representation of the total water consumption and the part of freshwater and the internal recycle. So as I have already told, this total water consumption mainly increases with the increasing capacity of the refinery, though the dips are because of the various factors like TDS of your feed water and the others, as I have discussed already. So after doing this water studies, the outcome of the study is basically the tapping off of the areas where we could do the water savings. So we have gone through the water balances of each and every unit and the overall water balance of the refinery, and identified the areas where the water could be saved or where additional water is actually utilized, which we can tap off and get the water reduced. One area is cooling towers, since this is the major consumer of a refinery, where we can optimize the COC of the city by utilizing a better quality water. Like if you are utilizing a treated ETP water, put up some tertiary treatment plant, some recycle plant to have a better quality water to feed to your cooling towers, to have our COC running at up to a level of 5 or 6, and you will require a very less quantity of makeup water. Installation of high efficiency drift eliminators, because in older refinery we have seen the drift losses are around 0.01, 0.05, where with the modern new high efficiency drift eliminator the losses are only 0.005%, that is 10% lesser. And then there are DM, ETP and recycle plant, if that is available in the refinery, that is case to case basis. We can do the audits of that plants also, and we can identify specific points where these plants can be remodified to have a better operation, better quality and better productivity of water. Condensers, where that is drained to the storm waters or in the closed blowdowns, and then it is routed to ETP, that can be tapped off and can be directly used as a cooling water makeup. And service water, drinking water are the 2 areas where normally there is no regulations, no flow meters. So we have recommended for flow meters at appropriate locations to have a check on them. And if you have a coastal refinery, we can explore the option of going for a seawater desalination plants. So with this, this is our recommendation, which we have, the total recommendation we have defined in short term and long term goals. Short terms are which can be completed within 2 years, and more than 2 years goals are written as long term goals. And this graph represents that if we implement this short-term and long-term goals, the water consumption per meter cube, per ton of crude processed are definitely going to reduce. And with this note, I am happy to say that most of our short-term goals has already been implemented by the refineries. Thanks to all. And our presentation was with the motto to intriguing the idea, do the water audit in a regular interval to get your freshwater consumption reduced. This will in turn save the money for you also and for a better sustainable future for us all. Thank you so much.
Thank you. Next, please. Anybody else left over? Okay, there are total 10 presentations given by various companies. So I take it that there is no more presentation. It means no more posters are left out. So we'll break for the time being, and I'll find out. Yes, please come over, Dr. Garg.
Also,
Okay. Come.
बैठा हुआ इधर ही आ जाओ पास में।
You may not remember, in '99 we had done that deep water conference at the time.
Yeah, I
So
remember.
that session was there.
Deep water.
That time you, I think, just left Gale, I think, after that.
हाँ सर, क्या डिसीजन करा आपने? कितने हो गए टोटल?
Total 10.
10। तो सबको देना है या कुछ डिसाइड किया है?
अभी सबको देना तो दे दो।
हाँ दे दीजिए।
हाँ?
दे दीजिए।
Better to give to everybody.
हाँ तो पहले फर्स्ट फ्लोर को तो पहले करिए। इस ऑर्डर में तो नहीं देने हैं, लेकिन जिस ऑर्डर में आप चाहेंगे।
Okay. Then
भारत पेट्रोलियम की वो था ना, वो लेडी भी थी और
yeah. This is one. This is number 2.
ऐश्वर्या अभी मैं लिस्ट दे रहा हूँ, आप अनाउंस कर देंगे। इस तरीके से ये लोग पहले 4 अवार्ड बैंक लाएंगे, आपकी ठीक है, एक दे दो, बाद में कोई प्रॉब्लम नहीं। नहीं ऐसा कुछ नहीं, ऐसा कुछ नहीं। ऑर्डर ऑफ प्रायोरिटी बस हो जाएगा, बाकी 4 हो गए ना।
तीन किया मैंने।
ठीक है, 4 कर दिए, उसके बाद फिर कोई फर्क नहीं पड़ेगा, क्योंकि जिस ऑर्डर में प्रेजेंटेशन हुआ है उस ऑर्डर में नहीं होना चाहिए बस।
वो ऑर्डर में नहीं दे रहा मैं। I'm also saying
ऐश्वर्या विद्या
मेरा तो यहाँ 1 BPCL 2 EIL 4
ऐश्वर्या ये 1 इसको स्टोव वाला 2 दो ये है और 3 ये है और 4 ये है, बाकी सबको फिर चीज़ हाँ हाँ देती है और वहीं से बोलो और आनंद ये बोतल 100 रुपए की है।
So, ladies and gentlemen, the results are out. Sorry, apologizing for the delay, but the jury has decided on the presentations, and I'm very pleased to announce that the award for this paper, the poster paper presentation, the first award goes to BPCL, and the topic for this presentation was Star Stove. Can we have the presenters? I'll request Dr. Anand Gupta, Additional Director General Development, Directorate General of Hydrocarbons. We are very pleased to have him in this program today. I'd request him to please give away the memento. The first award goes to BPCL's, where the topic was Star Stove. So please give a big round of applause for the poster paper presentation, the first award. Now let me announce the award, the second award, and the second award goes to EIL, and the topic was, I think it's Mr. Anando Raj. Can we have Mr. Anando Raj? EIL? Congratulations, Mr. Anando. Time to announce the third award. The third award goes to Mr. Naveen Gupta. I guess it is Mr. Naveen Gupta from ONGC. Please give a big round of applause to him. Congratulations, Mr. Gupta. And the fourth award. The fourth award goes to, again from ONGC, the award goes to Mr. Chunilal Chatterjee. Congratulations, Mr. Chatterjee. Can we have Mr. Chatterjee? Okay, he's not here. So, so these were the first 4 awards, and next, I'd like to thank all of you who gave the presentation. These are in no particular order. Yeah. Yeah. So I'll request BPCL's Miss Monica to please, and Mr. Nagarjun. Yeah. A very good, great presentation. Thank you so much, sir. It was indeed a pleasure to listen to all of you and see all of your presentations. Thank you so much for having joined us. Next, I'd invite BPCL's Mr. Anirudh Kulkarni. Great presentation. Thank you so much. I'll request Mr. Kulkarni to please, Mr. Anirudh Kulkarni, is he there? Yeah. Next, I'll request Mr. Maheshwari from BPCL. And Mr. Arun Rajgopal from BPCL also. Please. Yeah. Mr. Arun Rajgopal, Mr. Maheshwari, Mr. Das from Engineers India Limited. Sorry, Ms. Das, Antara Das from Engineers India Limited. And then also request BPCL's Mr. Srinivas Prasad for excellent presentation on integrated refinery and petrochemical project. Am I leaving out anyone? I guess I have announced all the names. I think I have not left out anyone. Yeah. So thank you so much, Mr. Prasad. So congratulations to the winners, and thank you so much to all of you for participating in this very, very innovative idea, very innovative paper presentation, as Dr. Garg said, that is being done in the world for the first time. And I'll now request Dr. Garg to also felicitate the jury member for this poster paper presentation, Dr. C.R. Prasad, former CMD GAIL India Limited. I'll request all of you to please give a big round of applause to him as well. And thank you so much, Dr. Anand Gupta as well, for having joined us and giving away the awards. Thank you so much, Dr. Gupta. It was indeed a pleasure. Please give a big round of applause to him as well.